Hello and welcome. Good evening, everyone. My name is Gopal Krishna Anand, Associate Editor of Thermal Control Magazine, and I welcome you all to the Thermal Control Magazine's interactive session on advancements in low GWP refrigerants. My colleague, Ms. Darshana Bhadra, editorial, Thermal Control Magazines, will introduce the panelists and moderate the session.
Thank you, Mr. Gopal. Hello, everyone, and welcome to Thermal Control Magazine's interactive session on advancements in low GWP refrigerants. An ideal refrigerant should possess low global warming potential, non-toxic, non-flammable, and zero ozone depletion potential. The current generation of refrigerants hydrofluorocarbons have zero ozone depletion potential. However, they have significant GWP when released into the atmosphere. However, the Kyoto Protocol lists HFCs as greenhouse gases because of their relatively high global warming potential. The growing international emphasis on global warming mitigation has stimulated interest in new generation of low GWP refrigerants. Many new synthetic refrigerants have been reported as alternative refrigerants with very low atmospheric life, GWP, and zero ODP. The increasing adoption of lower GWP, HFC, HFO blends well support the transition with non-flammable and low GWP mildly flammable refrigerants available. The world is looking for next generation of refrigerants. We will continue to face several issues in identifying a suitable refrigerant that poses no harm to the environment. However, there is a pressing need to develop new refrigerants and develop better equipment to use them. On this note, we have come together, witness an engaging interactive session on advancements in WP refrigerants. Ladies and gentlemen, it's an honor and privilege for me to introduce you to today's distinguished speakers, Avinash Shaligram, HVAC advisor at Drone Vionics Private Limited, Mr. Sarjay Rao Bhavar, research analyst at Blue Star India, Dr. Kaushal Kumar Jha, founder of Noonray Energy Private Limited, adjunct professor at IIT Madras, Mr. Pavan Surana, promoter, Coolmax Enterprises, Mr. Ashish Matto, manager, Klimavinita India.
My first question is to Dr. Kaushal Kumar Jha. Dr. Kaushal, why have the low GWP refrigerants been gaining more attention and why is their demand increasing?
If I have to tell you in very simple language, GW represents to something known as global warming potential. That means every refrigerant has a particular number and the reference is CO2. It's considered as CO2 global warming potential is 1. And anything beyond that is marked with the reference with the CO2. So if you look upon on mobility sector, the first restrictions which has come is that you should have 150 and less GWP. That means over the time, the temperature increase because of the refrigerant, because it works like a greenhouse effect, a greenhouse gas, so that the temperature increase should not impact our green Earth, our planet Earth. That's what lower GWP is important. I'm done on that particular thing.
Okay,
so
thank you. Thank you, Dr. Kaushal. Certainly, the low GWP refrigerants should help address climate change issues and greenhouse gases.
So, in fact, we should also not forget about one number. What we have been talking in the past is ozone depletion potential. Fortunately, now whatever the refrigerant we are talking about has a zero ozone depletion potential, because that was another nightmare in the past. Now, at least we have overcome this one. Now we have to overcome with the lower GWP refrigerant. And if you look upon CO2, CO2 itself is a refrigerant. Only problem is that we don't have much development done on that particular area. So hopefully in future, we should be able to use that itself as a refrigerant.
Definitely, Dr. Kaushal. Mr. Avinash, so he was talking about the CO2 as the refrigerant. So what implication do you see for HFO, hydrofluorine, and natural refrigerant like ammonia and CO2 as better alternatives?
So first of all, good afternoon to all. See, HFOs which have being developed, which are already are developed and which are coming up in the future are, the unsaturated HFCs. Actually, we had a problem of hydrofluorocarbons, HFCs having higher GWP. Okay, so now the chemical companies have basically it is to do with the atmospheric lifetime. All these earlier CFCs and now even HFCs, they have very large atmospheric lifetime. So the now new olefins, which are actually unsaturated HFCs, they have a lower atmospheric lifetime, and hence I think that is one of the reasons why they have a low GWP. So HFOs definitely are going to be, already are being introduced and will be used. Regarding CO2, see, first of all, CO2 is a transcritical, it is not in the conventional system. Its critical temperature is only 31 degrees centigrade. So it operates under what is called a transcritical cycle. So it's a different, system. And as Dr. Jha was saying, actually CO2 as a refrigerant has a lot of advantages. It's, GWP, as he was mentioning, only one, which is the lowest possible. Okay. It is, as far as India, we have to look at our India, our country, our situation. Availability is good. There is no issue. Whereas HFO means we will be always dependent on, import and cost, and so many issues will be there. So CO2 has definitely advantage, but there are some challenges. Actually, I would call it challenges, and the main challenge is the efficiency. So those things, there have to be developments which will have to be there. Ammonia has been used in the past in India and will be used. Ammonia is a most commonly used refrigerant in industrial refrigeration. So that will be continued to be used, and it is a good refrigerant. Of course, it has a, it comes under B12. It has a, toxicity, lower flammability, but that's why it is used in industrial application. But it has been used and it will be used in future. So natural refrigerants have good potential, especially in Indian conditions, I feel. Now there are issues, there are challenges, what we all know about, the flammability part. So that means the safety precautions have to be taken. And most important, as far as India is concerned, training of the technicians, because that will be a very important factor in the few coming years, to handle these new refrigerants.
Definitely, Mr. Avinash. I think further research on natural refrigerant is the need of the time now. Would you like to add to it, Dr. Kaushal?
If you look upon the topic, what I would like to, what I would have been planned to go for this session is mostly on the mobility sector. And the problem with mobility sector, you don't have any alternate other than the vapor compression system. And unfortunately, you cannot use ammonia as a refrigerant there. I accept the large industrial houses.
Yes.
And in fact, even in the large industrial, other than the cold storage and other things, if you look upon, even for the HVAC application of large buildings and other things, we don't use ammonia.
No.
So the toxicity, even though it's issues, but it's so remote and so other places, it's not much concern to that. Another fact, what you have to look upon, that being a very good refrigerant, the COP of the system, ammonia based, it's basically work on vapor absorption system. The COP performance are only suitable for, especially on the food, cold storage and other things, but does not harm much to the environment. In that way, it's really good. But what we have to look upon, how we can move on the commercial segment, especially like shopping complexes, our own houses, where now every house has the air conditioning system, as well as the mobility sector. And that's where you have all the problems right now. So with that note, I would hand over to other panelists.
Would you like to add something to Dr. Kaushal, Mr. Pawan?
Ammonia, why it's not that good is because it has a pungent smell. I went to the ammonia plant recently. So if you put ammonia in house refrigerants, in domestic ACs, what will happen is people will get scared that why such a smell is coming. And it can cause, really bad, tears also may come. That's one reason. Also, CO2 is having GWP1. It's not the lowest. Lowest is 0, which is there in hydrocarbons. I think water is also a refrigerant. So 0 is the lowest GWP, and we are having 0 GWP refrigerants, which is hydrocarbons. So, and coming to the HFO thing, why HFOs will be popular is because they are going to be manufactured in India soon, 1, 2, 3, 4 YF. So we need not depend on imports soon, because companies are having proposal. Also, they are going to plan for some capex. So we need not import 1, 2, 3, 4 YF after certain years. R32 has been started, manufacturing. SRF is doing that, and even Navin Fluorine and GFL also, they say that we have plans. So Navin Fluorine International Limited is started doing R32, which is a low GWP when compared to R22. It is having a GWP of around 600. So ammonia is a good refrigerant, but it has some problems. Similarly, hydrocarbon is a good refrigerant. It's having zero GWP. Ozone depletion is zero. But why don't we use it? Because it is extremely flammable. And practically, what happens is when you store it in cylinders, inside the city, in very big cylinders, in 60 kg capacity, then you have restrictions in storage because you cannot store more than 5 cylinders of flammable gas as per the rule, and you cannot transport more than 25 cylinders. So when you do things which should not be done, then again the dealers will be in problem, because the government will tell you are not supposed to store, and many dealers don't have license to store and fill because they are little difficult to get. So everything what will happen is they'll go out of city, and we have to keep all hydrocarbons out of the city, and also still you'll be in danger only because it's a bomb. Hydrocarbon means what? Propane, butane. Gets caught means big blast will happen. You can't store it in 20,000 kg. It is little bit risky. So HFO wins in all these things. The HFOs which are coming in future, having a GWP of 4 or around that, 1, 2, 3, 4 is having 4 GWP. So there they are winning in many aspects. There also some problems are there. We'll come to know in further discussion. In my PPT also I'll show you. Yeah.
Thank you, Mr. Pawan. What are your views on this, Mr. Ashish? Do you want to share your views about this?
First of all, I would like to thank you, for letting me in a panelist of learned gathering. In terms of, I'm from a chiller background. I'll give you a perspective of a chiller industrial background, what we talk about. For example, in air conditioning, when we see vapor compression cycle, it will require refrigerants every time. And as we grow, our economies are growing, our countries are growing, more and more people are, have started using air conditioning systems in their homes, also in commercial applications as well. So since we already have banned a lot of refrigerants which were very toxic to our ozone layer, so that we could have zero ODPs, which is ozone depleting potential, and now we are moving towards better refrigerants which are having lower GWPs, which is again global warming potential. It should be very less. In terms of chiller industry, if I talk about the major refrigerant which is being used currently is R134A. When I talk about this refrigerant, it's a very great refrigerant, but the only issue with it is its GWP potential. It's roughly 1300 GWP. When we talk about GWP, I would like to highlight on that topic. It's when we say CO2 is having 1 GWP, it says the effect or the heating effect of a CO2 for a year of 100 years. It's an effect of 100 years of a life of a CO2 when I talk about. And this refrigerant is having, 1300 years of CO2 life into 100. So it's a very good impact, in terms of global warming when I talk about. But again, when we move towards better refrigerants, when I talk about Mitsubishi, the Klima Veneta, we are already ready with HFO machines. But the main challenge which we face currently is availability. And one challenge is availability. Second is when we talk about its flammability also. So as per ASHRAE, there is a table by which we categorize our refrigerants within A category and B. A being low toxicity, B being higher toxicity. And when I move from A1 to A2 and A3, the flammability also increases. So these the new refrigerants which we are seeing are A to L. They are not highly flammable, they are mildly flammable. But yeah, you have to risk a bit to get better global warming potential refrigerants. Having said that, when I talk about global warming potential to be low, a refrigerant is not only having a direct impact, it's also having an indirect impact. So when I talk about as a chiller, the power consumption in a plant room which is having a chiller, 60% is consumed by a chiller. And when you are consuming energy directly, okay, there can be a release of refrigerant as per a study within 3 years or 4 years, entire refrigerant gets leaked out and you have to top up the chiller. But when I talk about indirect effects, the indirect effects are huge. Like for example, you're having you're using a chiller. For example, you purchased it for 60 lakhs, for example. The annual energy cost for that running that chiller is 60 lakh rupees. And the indirect effect is the CO2 emissions because of the power generation when I talk about. And the terminology that is being used to, calculate both the impacts, direct and indirect. It's called TEWI. It's total equivalent warming impact. And when we talk about these values, then the refrigerant with even bit higher, GWPs, are proving to be more sustainable as compared to those refrigerant. Although I have gone into lower GWPs, but my another very important point is efficiency of the chiller. I need not to compromise on the efficiency of the chiller. So that's main criteria also. It should be a main criteria again for a refrigerant industries to, move forward.
Thank you very much, Mr. Ashish, for highlighting those points. Flammability and toxicity, that is also one of the main concerns. Mr. Sarjirao, what are the views you want to share on this?
Everyone shared their views on refrigerants, like quite covered. I would like to put up some different perspective as a OEM point of view, original equipment manufacturer point of view, what they want. And like, obviously I'll be covering those in detail in my slides, but such agreement come in, like if suppose certain ban is coming in and it puts effort, like it puts pressure on the industry to, transition. And when transition happens, that is the critical phase of the, critical phase wherein we need to put a lot of effort and we need to identify the refrigerant and we need to check into account whether it is flammable, non-flammable, energy efficient or not, like, and like whether competition, what is competition is following, or like what, global perspective, whether it is accepted or not. And the research is, enough to judge that refrigerant is, good or bad in that sense. Obviously, regulation takes care of the environment, but when it comes to the industry, our industry, HVAC industry, we need to take care, we need to make a product which, ultimately, we need to sell it to the customers and like that they, they should, take benefit of it. So yeah, that's my views.
Yeah, thank you, Mr. Sarjirao. Additionally, what are the evolving opportunities in the refrigeration market?
What I could say I worked on like almost every market across the globe. For my 8 years of experience, I worked for Indian market, SAARC countries, Middle East, Japanese, China, or you take Europe or US is the currently I'm working on. So obviously the challenges are there, and the refrigerant industry is moving to to overcome those challenges across the globe. However, I would like to say there is not a single solution to this problem. There is not a single refrigerant to replace everything. Each and everything got variety of refrigerants coming in. So challenges are there, I would say.
Yes, thank you, Mr. Sarjirao. Challenges are there and new refrigerants will impact the new markets. Mr. Pawan Samarat,
Yes,
Mr.
yes.
Pawan, coming to
Yeah.
you. Why is a shift towards low GWP potential refrigeration getting prominent in the refrigeration industry?
Because of climate change. Because see, the glaciers are melting and our industry is also a part of that. Yes, of course, carbon dioxide is emitted by many means, like many industries, but refrigerants is also a small part which is doing these things. And if suppose we would not have evolved, if we would be in that past, where we were using CFCs, where like we had R11 gas, which was very dangerous. It had ODP also and GWP also. Both were there in large quantities. So what will happen is all glaciers will melt. So hence the need is to go towards the low GWP refrigerants. And I can tell you that there are refrigerants. For every need, the refrigerants have come. But it will take some time actually for them to get tested, whether they are efficient or not. And there are replacements for all now. And I'll show you in the slides also. So at least some refrigerants are there. That's why to overcome the climate change problem, where 2047 is there, no, that's a very long time. To overcome that, we should shift to low GWP refrigerants little faster. I'm not saying we can shift in 2, 3 years, 4 years. It's not possible, but we can do it little faster. And if we don't do it fast, the earth temperature will rise by 1.5 or 3 degrees, something like that, 2 degrees, and it will cause a big problem. Then you'll have rains in some areas where you should not have at that point of time. For example, March, if you have a rain in a wheat growing area, you won't have wheat, so you'll not have your roti. The demand will go up for wheat and the poor will suffer, not the rich. Hence the need for low GWP refrigerants, that is very, very important, because poor people will suffer a lot and there will be floods. In floods, everybody is going to suffer, not just the poor, but the rich as well. Then there may be also different things, like there may be a snowfall, there may be some droughts at some place, but the rainfall is going to be more. And instead of having, like, suppose in a city like Chennai, if it rains in November, it can rain in March also, in May also, suddenly. So what happens when sudden rains come is, it will get flooded here because the drainage system is not that good in Chennai. So there are many areas in the world which are low-lying areas. They will get totally finished, and that will cause a lot of problem in many parts of the world. Already we are seeing what climate change can do. So we need to preserve the glaciers, not just melt them off.
Thank you, panelists, for exchanging your valuable thoughts on today's topic, advancements in low GWP refrigerants. We hope you enjoyed the session thoroughly. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Avinash, Mr. Sarjara, Mr. Ashish, Mr. Pavan, and Mr. Kaushal. I would also like to thank Mr. Gopal Anand and Mr. Prasad Nair for taking this initiative. We want our delegates and viewers to stay connected with us on our social media handles. Thermal Control Magazine is available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. With this, we want to announce the closing of today's session. Request you to stay tuned for more such sessions. Thank you.